Hey, hi. This is a project by Narayanam, Arjuna Moitro, and Ogi Mitro, students of 5 years Integrated Dynasty, 10th semester, University of Kalyani, Department of Statistics.
We worked together to build a logistic regression model for a banking dataset. In this presentation, we are going to briefly take you through the project we have done. Next, the problem statement. A bank always has to be careful while lending loans to its customers. Being impetuous might cause a lot of damage to itself. Here, we have the data of customers from the US who took loans in the past 10 years. If a new loan application arrives, we must be able to predict whether that would turn out to be a good loan or not. Now, let us look at the dataset. Data is based on loan issued in the US. There are 148 explanators, more than 1 million records, and the target variable is loan status. The 148 explanatory variables are given in the slide. In the pre-processing stage, the data needs to be cleaned first. It must be free of missing values, categorical variables, and many more which we don't want to include in our model. The missing values. We have tried replacing the missing values in the data with the all three min, median, and mode to check which one suits better. And that was only to witness a huge artificial spike in the data. So the only thing we have come up with to deal with the missing values is dropping them. We have dropped the columns whose percentage of missing values is more than 40%. By doing this, we can save a lot of data from getting lost. And then we dropped all the other remaining records with NA values. After getting rid of NA values, let us split our data frame into training and test datasets. We have split them in the ratio of 70:30. Now that our data is free from null values, it's time to deal with the categorical features. For easy access, we separated the numerical and categorical features and stored them in two different data frames. The column names mentioned in the slide are the columns in the categorical variable data frame. Next, feature engineering with datetime columns. Datetime columns also fall into categorical variable dataset. There are 4 datetime format columns in our dataset. They are given below. After converting them to datetime format from Panda series, we need to make out some meaningful time durations out of them. We drop the zip code column as it doesn't give any info about the place, as there are around 41,000 zip codes in the US and only around 900 unique value zip codes in the dataset. Codes are in the format of 123XXX. Half of the code is hidden. Next, comparing variables with target variable to check if they have a significant effect on it. For example, checking the state in which the person lives in if it has an effect on loan status. If there's not much variability in good loan and bad loan percentage, then we exclude the column. After filtering the columns out, let's identify which column have less than 20 unique values so that we can apply one hot encoding to convert them into numerical. Note, first identify columns with only 2 unique values so that we can label encode them to avoid unnecessary dummy variables. Now that all our categorical variables turned numerical, we are going to club both of the data frames. The next is treating multicollinearity. We plot a correlation matrix to find out correlation between each and every variable. If correlation is less than minus 0.5 or correlation is greater than 0.5 for any two columns, then one of the columns gets excluded. The dataset is now ready to be passed through the model. Before doing that, make sure that you scale the data to avoid false model assumptions. Here is the confusion matrix for our model on test dataset after training. In this slide, we provide the classification report. Summary. Our model performed with an accuracy of 98%. Performance can be improved by using different encoding techniques or other dimensionality reduction techniques. Lastly, thanks to Professor Ganesh for his valuable guidance. Thanks for watching.